Good afternoon, everyone. I'd like to thanks to Professor Brian Story to inviting me to come to the Christchurch Antarctic talk. It's a very nice opportunity for me to introduce about the Korean program to the New Zealand scientists as well as general public. And first of all, I'd like to apologize. I'm not a good speaker, especially not English speaker. And anyway, I try to deliver the message I like to give you. I'm come from the Korea Polar Research Institute. Is what I locate. Kopri is very near from the international airport near Seoul. Seoul is about 50 kilometers away. Incheon International Airport, it's only 20 minutes drive to our institute, very near. The Songdo is called the Songdo area. Songdo is a very new, modern city. It's built only 10 years ago. So we have our property, and we make a building, and we moved into 3 years ago. It's a pretty new building. So it's a Polar Research Institute. That means we work in Arctic and Antarctic too. Both poles we worked. By 2 stations in the Antarctic and 1 station in the Arctic. And we have an ice-breaking research vessel, Araon, in between. So what I like to talk is some general information about Antarctic. I believe many of you probably knows about Antarctica better than me, but some of you are just come for the interest, so give us very little information on Antarctic, and then I'm going to talk on the why Antarctica is so important for us, especially for scientists, and how is our new station looks like in the Ross Sea, and what kind of science we are doing, and what is our future plan for science in the area. Okay, this is the map of Antarctica. You probably know, you're probably familiar with this map. The white continent, okay? It's covered by ice, of course. That's what we call the 7th white continent. Antarctica is normally called. And you see many small dots. It's Korean and the English is get together. All these dots are all the station, mostly wintering station in Antarctic. At the moment, around 40 wintering stations are occupied by about 19, 20 countries. So every country has operate 1 or 2 stations to do the research there. And this is the station we newly built. It's Jangbogo Station. It's the Ross Sea. We are here. Okay? New Zealand here, and Australia here, and here is South Africa, and South America is here. So this is the Pacific side of Antarctic. This is the Indian side and the Atlantic side. So if anybody asks me what is the Antarctic look like, what's the climate, I used to say this is the coldest and driest and windiest place in the Earth. It's quite sure, right? But why we have interest in such a cold and windy and driest place? Very simple and quick answer is the size of the continent. See, China is like this, much bigger than China, okay, and bigger than India. So the area is almost equal to China and India combined. It's a pretty big continent. So my argument is that if we like to understand about Earth system, we should know this big continent. It occupies about 10% of total landmass on the Earth. It's very important to know the Earth system. And second, the ice cover the continent. The ice is a thick place. It's more than 4,000 meters thick, 4 kilometer thick ice. Very, very thick glaciers cover. And the average 2.4 kilometer of ice. So think about the amount of water. If 2.4 kilometer thick ice covered about twice the size of Australian continent. A huge amount, right? It's the biggest reservoir on the Earth. So naturally, we can think about what happens if the old ice melt. It looks like this. We estimate if all ice on the Earth melt, then the sea level will rise about 70 meters. Then 60 meters of contribution come from the East Antarctic part, about 5 meters from West Antarctic, and 7 meters from Greenland side. So about 70 meters in total, meter of sea ice will rise. So the problem is the most of big city, the human live, are located very near the coast, within 10 meters, 5 meters. Okay? New York and Tokyo and San Francisco, Los Angeles, all about 5 to 7 meter level, located level. Even in Korea, Incheon, Busan is about 20 meter, right? And Seoul is 40 meter. I found Christchurch, Avonhead is 30 meter. I found the Avonhead, I visited the Avonhead Park, and there's a mark that is a 28, 30 meter elevation. So, Christchurch will be under the water too, just in case. Okay, then we move to the global change. The global change is the most important topic. The earth science should give answer in 21st century. Of course, the biggest theme, we should solve it. Obviously, the global change means many different elements like ozone hole depletion and warming and sea level, all a part of global change. Then we can have a question that we can study global warming or global change in New Zealand or in Korea, in China, many places. Why? Why you should go to Antarctic to study that? Such a harsh place. Why we go to harsh place to study that? The simple answer is that this is how much surface temperature rise for the last 100 years. So black means the biggest rate of increase of temperature. See that the blue, the black, the red one is mostly in the north part, the Arctic part. Siberian Arctic part, we experience most big rapid increase of temperature. And the Antarctic too, especially Antarctic Peninsula, we experience a lot of big hike of temperature last at least 50 years. In Antarctic, it's a little bit complicated, like that. In Pacific side, very rapid the increase we can observe. But East Antarctic is not very clear. Some part is not, getting cold sign. Somewhere it's very warm sign. It's not clear, but it's very, very prominent in the Pacific side and Antarctic. And we measure the temperature rise of Antarctic Peninsula area. The rate is about 2.5 degrees Celsius higher for the last 50 years. It's a very big amount. For the last 100 years, the average temperature rise in the whole world, the whole Earth, is about 0.7, 0.8 degrees Celsius, 100 years. But Antarctic Peninsula is 2.5 degrees for 50 years. So it's about 6 or 7 times faster than any other place on the Earth. So this is a very important area to study on the warming trend and global change. So many scientists like to go to observe this phenomenon. And second thing is the Antarctica has very important data to show the past climate changes. This is the data. This data comes from the Antarctic ice core, or more than 3,000 meter ice core. Data shows very good, very accurate changes, temperature and atmospheric composition for last 800,000 years. This is the longest record you have. Very, very accurate high resolution data. In this data shows just the concentrated center part. This is a temperature changes of this is a present position to 800,000 years old. So we see a lot of changes of temperature, around 100,000 years repetition, roughly. We are in here. We are interglacial. The glacial period is the last glacial period. Very rapid, many changes of glacial and interglacial cycles we observe. The other point is correlation with the atmospheric composition. These are CO2 changes. Very correlated, right? High temperature correlated to high content of CO2. It's a very, very clear sign. So we say, okay, greenhouse gases, we can buy, it's exactly matched with the model we have. Okay? See, the other thing is we have to notice is present content of CO2. The CO2 is 386 a few years ago, but at the moment already it passed 400 ppm. The content of CO2 in the air. But let's see these contents: 358, 400. It's much higher than any period for the last 800 years, 8,000 years. So the amount of CO2 exceed, very significantly for the last 1 million years, I think. So I may summarize that the Antarctica is undergoing very rapid changes of climate, so it's worth to study. And Antarctica gives a very good record of good data about past climate change. So it's a very good area, very ideal area to study on the global changes. So study on this climate change, Korea started the Antarctic program from 1988 when we built a station in the Antarctic Peninsula area. It's called King Sejong Station. It's located in the coast too. The small island, the King George Island, is about 80 kilometers long, covered by glacier mostly. 80% of land is covered by glacier, and we set up a station there. In summer, it's whole melt. It's an ice-free area in summer. So it's pretty. You see that it's located at pretty lower latitude than any other places. So it's a very good area to access by ship or by air. And then 20-some years later, we have another station in the Terra Nova Bay in the western part of Ross Sea. This picture was taken in 2010, February, when I visited this area to looking for a site for a new station. So actually there's no station at that time. And the last part of fast glacier is moving, melt away. In early February is the warmest season in a year. And when I visit here, I instantly found that, this is a very good place. It was to set up a station. In old Korean belief, we have some condition of ideal spot. The Korean ideal spot is We have mountain in the back, normally, the water in the front, and left and right side of a small hill. So it's kind of cozy place. It's an ideal spot, to build a house, and even some built a place, grave of our ancestor. It's an old belief of Korea. If you put a good place, good spot, put grave of ancestor in good spot, then the descendant will be prosperous in the future. It's a very long belief. But anyway, it's a very good place in any for any reason. Okay, not only the ideal spot of that belief, it's a very good place for doing a science. Especially, I like to point out that the place of Jangbogo is located at boundary between Eastern and Western Antarctic, exactly in the boundary. Very big changes of, very big difference of changes in east and west part of Antarctic. So we are stayed right in the middle. So it's a very good area to study both sides. And in Terra Nova Bay area, there's no permanent station. There's no winter over station. So we're going to set up a station and monitor the data year-round. It will be very good. We can provide very good data. And we have a station in the two ends of Pacific side. So if we connect to both sides by ship, then we can make a very good observing network between along the Pacific side of margin of Antarctica. So really, it's a good place for any different kinds of disciplines of science. Also, it's a very good place for the international collaboration, because in the Ross Sea area, many good science is going on by U.S., New Zealand, and Italian and German. Many good science program is going on. So it's a good opportunity for us to make a good collaboration with them. So for the boundary of East and West Antarctic is one example. I show you that the amount of melting, temperature changes are quite different in eastern part of Antarctic and western part of Antarctic. The circle shows the amount of melting in a year. Very, very big melting is going on along the Pacific part of Antarctic. But East Antarctic, a little bit increase of ice. A little bit thickening of ice is observed. So our station located right here, okay, in the boundary between East and West Antarctic. So it's a very ideal place to study on that. Not only the temperature-wise, but also dust, atmospheric dust. For example, this part is dust is mostly come from Southeast Asia and Australia, and this part is the dust come from the South America, and dust here is come from the other part. So we are located here. So we analyze ice core and analyze the dust there, then we know is in between the two different part of original dust. So it's a very, very ideal place to study many things. Also, as I told you, if we connect two stations by our ship, it makes a very good network of observation. Actually, not every year, but occasionally, the ship visit the Jangbogo station to King Sejong station. So a lot of measurement, not only in the sea, but stopped many places to make a measurement. So it's a very useful data we can provide. Okay, the construction. I'll show you something about our new station. When we planning for the new station, we think about construction of the station and operation, and then dismantling in 25 years later. And then we make a lot of effort to reduce the amount of fossil fuel. And total building area is about 4,000 square meter. It's a pretty good size. It can accommodate more than 60 people for summer season. Normally occupied by 15 to 16 people for winter. So now is the end of the winter season. So the people, 16 people stay for last winter. They're waiting to get out now. No. Okay, design concept. You see that the main shape of the building is by three arm shape. It's a quite unique shape, right? And this concept has come from the Asian philosophy called the concept of the three great absolute. Three great absolute means the old Asian philosophy believed that universe is composed of three big elements. One is the heaven. This is a heaven. The Chinese letter means heaven. This is earth and human. The three is the most important part of element of to make a universe. So the basic design concept is to make a balance and harmony between nature and human. This is a 4-story building, usually. Second story is floor 2 is here's floor 1. You call it. It's floor 0. Floor 1 is normally mostly accommodation and laboratories located, and floor 3 there's offices, and floor 4 is mostly communication and observation. The building, the construction was completed in 2014. So what it looks like this. This is the main building here, and this is a powerhouse. This is a garage, and these are all small. This is a emergency shelter, just in case of fire or anything. It's a completely isolated, independent living can make on these two buildings, and these are little separate observatories around. And this is our own visit in, I believe this picture was taken in somewhere in the mid-December or something. The outside is Polinia. The outside of Terranova Bay is always there's ice-free or a whole around the year because big Polinia outside. And the fast ice is normally 5 to 7 kilometers from shore. So our ship can have to break the ice to support our base for at least 5 or 6 kilometers. So in December, we can still unload our supplies on the sea ice. So what kind of, how it looks like in inside? This is a science facility. Looks like this. I believe it's a biology lab. And this is a meteorology observation. They launch a balloon every day. It's an automatic launch system of balloon. And this is a carbon dioxide monitoring hall around here. And this is a observation tower that is about 800 meters away from the main building, so it avoids any contamination. So they keep collecting the data on CO2. And living. This is a galley. And we have a big greenhouse. So they can supply self-sufficient of not full amount, but some amount of vegetable in the winter. And Antarctica is a good place to play golf. Of course, yes. Why not? We call it screen golf. You know the screen golf? It's very good. In the list, we can choose the many different golf course, even Pegasus or even Shirley. then all holes exactly shown in the screen. So it's a good time. How we gonna go? This is Terranova Bay, our Changbogo station here. Is a Italian station, Mario Zucchelli. It's about 7 kilometers away. It crossed the bay. And to go, it is a summer station. Now they start to occupy, and February, the Italian left the station empty and come back on this October again. Normally we go by ship from Littleton Harbor. It takes 8 days one way. If you're not very patient to stay on the ship for 8 days, you can fly, of course, yes, by aircraft. Yes. This is the civilian version of C-130 at L-100. We operate the aircraft with the Italian. So we cooperate with Italian for air operation. So this aircraft actually lands on the sea ice in between here. So ice is pretty thick enough, about 2.5 meter thick. So plane is is thick enough to land. But the end of November, the sea ice is getting thin, so we're not going to fly from that time. So we'll only by ship. Okay, this is the ship we are operating. And this is about 110 meter long, 90 meter wide. It can carry about 60 scientists one time, 25, excluding 25 crew member. And the performance is about continuous breaking of 1 meter thick ice at the speed of 3 knots. So it's good enough to in the Ross Sea area. And she's a very busy ship. She worked 6 months in Antarctic cruise. She employed 3 months in Arctic cruise. So whole around the year she's on the sea, on the water. Just like this. The ship just left yesterday from Korea. The ship left Korea and then she visit first stop in Hobart, and then get some fuel, Antarctic fuel, and bring it to our base, and then make a cruise here, come back and forth. She's gonna make 3 port call this season at Littleton Harbor. And then she'll move to Bellingshausen and another station in the peninsula, and then go back. So it's a very, very long trip. And this is about the total plan. This season, we estimate more than 120 personnel will moving back and forth, and including 80 scientists from many different nationalities. And we have some wintering member too. So actual number is more than 160 actually. It's a big number of people moving back and forth. We have 6 flights we schedule, and say ship carries not only scientists but a lot of cargo too. And for the science, this is the cartoon shows what kind of science we can do. The base, our base is here, and this is the Ross Sea. And there's a mountain about 100 kilometers away. It's one of the longest mountain in Antarctic. It's a trans-Antarctic mountain. It's more than 3,500 kilometers long. It's very long, more than 3 kilometers high, very long mountain chain. It's a good area for doing science. Geologists is happy about having a lot of outcrops in here. And inside the plateau, we can collect the meteorite, and we can do some astronomical observation, and we're going to make some drill to get some samples from subglacial lake, and some microbiology too. So it's lots of different kinds of disciplines of science we can do in such a good, ideal place to study. And it's a good place to observe aurora australis. It's a location. The latitude of our station is about 75 degrees south. It's a pretty high latitude. So it's very good to observe aurora. Okay, and meteorite. You know the meteorite is a fallen rock from the space. Victoria Land is a good place for the meteorite expedition. The last few years, we made a lot of expedition along the mountain to search for meteorite. And up to now, we found more than 300 meteorites from the Victoria Land. One of the precious one is the small one. It's only 94 grams. Very small, but very expensive because it's from the moon. Can you imagine how much money you can spend to get a rock like that from the moon? Very little money you can get the moon rock in Antarctic. It's a very cheap way. That's why I appreciate our government on that, but they never believe that though. And geology. I told you, geologist heaven. It's Victoria Land is geologist heaven. This is a Jangbogo station site here. And Scott Base is here, Ross Island. It's about 350 kilometers. So it's whole from the McMurdo to the northern tip is about 800 to 900 kilometers long. So along this coast, many glacier and rocks we can work. Especially geologists make a few spots. They make a few spots to study their own. This just shows the size of the area. It's a Korean peninsula. It's also about 800 to 900 kilometers, about same size. It's quite an interesting picture. Right? It's from the night view of Korean peninsula. It's very bright in the south. There's a border. It's completely dark in the north. Very big contrast. This general geology of Victoria Land. Victoria Land is composed of a lot of Precambrian metamorphic. And early Paleozoic, there's a big intrusive of granite tabor. And then middle Paleozoic to middle Mesozoic, we have a sedimentary, very thick sedimentary. And then Jurassic, we have a mafic intrusive again. So we have a sedimentary rock, a metamorphic rock, and an igneous rock. Good, very good. You have all the samples you can get. So Korean geologists have focused on few areas, have a specific interest for them. For metasedimentary rock outcrop. They choose Eureka spurs. It's about 300 kilometers from Korean base. They set up a tent like this, stay outside for getting a sample. This is the area they work. Couple of outcrops they studied with the sedimentologist and the micropaleontologist work together. They make a very detailed analysis of rock and layer. And also early Paleozoic trilobite fossils are very abundant in that place. And another big project we are doing is a glacier system This is a flow of major glacier in Antarctic. We are here. This is one of the big glacier system in Antarctic. Third biggest glacier system in Antarctic. It's called the David Glacier and Drygalski ice tongue. Drygalski ice tongue is right there, small pit. Drygalski David Glacier is one of the fast-growing glacier in the Antarctic now. It moves about 700 meters per year. And the Drygalski ice tongue plays a very important role to control the speed of David Glacier for the last 4,000 years. So the David Glacier is very near from our station, within 100 kilometer range. So we can easily get there by helicopter, make a lot of measurement. This is a very interesting area. You see that in the summer season, in January and December, there's a lot of melting we can observe. The surface melting. A tremendous lot of water is melting we can observe, like a fall in the crevasses. We observed in many times, almost every year we can observe kind of scene. So our scientists picked David Glacier and Drygalski glacier system to study the interaction between the ice and solid earth underneath, interaction between ice and ocean, interaction between ice, air, and ocean, interaction of ice and air, and its impact on ecosystems. Very comprehensive study on the fast-moving glacier. It's one of the most rapid changing environment in Antarctic. So, for example, they put a lot of geophysical measurement, observation post deployed. For example, it's called Amigos system. Amigos is it has a lot of sensors like a meteorological sensor and the camera and GPS. It's a kind of complete geophysical observation system for whole year-round observation. And seismic network too. Not only seismic activity itself, but the ice movement of ice make a small noise. So we can continuously detect the noise by the flowing ice over the rock. So we can measure the ice movement more closely. And this is a kind of observation system we deployed for last 3 years. Have a few tens of GPS, Amigo system, seismic system. We have ocean bottom observation. We have mooring, and we have so many different kinds of continuous measurement, continuous monitoring site was set up. And not only on the ice, but we also work in the sea. This data we took with the New Zealand scientists, the GNS scientists, by our ship. This is a Ross Island, and their station is over there. So make a cruise. This is a very, very important area to see the tectonics of connecting the Ross Island Erebus volcano and other volcano, the Melbourne volcano in the Terra Nova, making a two line of connection. Many prominent underwater submarine volcanoes can be found. It's one of them. You can make a lot of sea bottom topography map we can produce. And ocean research too. For example, in the Ross Sea experiment of last year, scientists get a lot of sediment core, not only for Antarctic along the coast of Ross Sea, but also the way in between those New Zealand and Antarctic. Many cores. This expedition, there are many scientists from other countries like U.S. and there are many of New Zealand scientists are involved in this cruise. The other important ocean research is going on in the Amundsen Sea area. Amundsen Sea is the further east from the Ross Sea. It is the least studied, the least visited area by ocean scientists because it was a very thick ice covered all the year. So very difficult to reach. But these days, last couple years, ice getting loose, sea ice getting getting thin every year. So more and more ships can visit there. So far, not many ships actually visit. So in our case, our ship visit this Amundsen Sea area every 2 years. Put a lot of mooring system and a lot of oceanographic measurement. This is a very important kind of study. It's also a very international collaboration program. For example, especially in the Pine Island area, we observe huge amount of ice rolls. We measure every day, every year. Mainly because of sea ice. I mean, the temperature of the sea and temperature of water actually rise, and it melt the ice from the bottom. So the effect of the water temperature is much higher than effect of surface temperature to melt the glacier away. And this season, we are planning to have a Bellingshausen expedition cruise. That means it leaves Christchurch, and then this is the final area, destination we can go. But in between, this is Bellingshausen Sea. So we'll make a scientific cruise and measurement in the Bellingshausen Sea. This is a first attempt, Aron's attempt to study in the Bellingshausen Sea. What we are going to do is, for next 3 years, we're going to make a study on paleo oceanographic and paleoclimate changes by normally, especially with the sediment core. We have very long core system. We expect at least 20 to 40 meter long core we hope to retrieve in there. The other very interesting project we started from this season is the iron fertilization project. It's a very, very new one. And the target area is the Bransfield Basin because the area is a lot of mixture of cold water from the east and west. So this is an ideal place to study on the iron fertilization project. This project, I believe 3 or 4 New Zealand scientists involved in the cruise. You know what is the iron fertilization? The theory is you put iron, and then more biology, more plankton, more plankton. It consumes much more CO2 in the air. So we like to know how much CO2 can be consumed by the plankton in the effect of the ion fertilization. That's the main basics of the study. And then this is also a very interesting study on the connectivity of climate variation between the southern mid-latitude and Antarctica. That is from New Zealand. GNS scientists of New Zealand, they drilled core from Lake Oahu. Lake Oahu, this in the South Island, of course, and then compare the data with the sediment core from the Ross Sea, how they connect, whether they have a similar kind of they make a similar kind of climate variation, or there is something different. Where is the origin of the dust? Where the origin of the sediment comes from? This kind of things they're going to study. So this study just studied. So GNS scientists get the core from Lake Oahu already, and Korean scientists get a core from western part of the Ross Sea. So we're going to compare that in the future. The pretty long core. New Zealand team retrieved more than 80 meter long core from Lake Oahu, and it probably cover the sediment age of sediment cover from after LGM, last glacial maximum, to Holocene. It's a very rapid sediment. It shows very rapid sedimentation. So we have a very high resolution data we hope to retrieve. And then another new project we're going to start this season is the conservation of marine living resources in the Ross Sea. Ross Sea is a very, very important area for biology. For instance, it's a big habitat of Patagonian toothfish. It's called the mero in Japanese. Mero is more well-known name for Asian, but Patagonian toothfish is the original name. And Ross Sea is an area of 38% of penguin, Adelie penguin habitat. And Ross Sea is an area of 26% of emperor penguins colonies. Ross Sea is the area of 30% of Antarctic snow petrel lives. Then Ross Sea area is 6% of Antarctic minke whale lives, and 45% of weather seal in the Southern Ocean live, and 50% of Antarctic killer whale lives, and a very high invertebrate biodiversity contains. It's a very good area to study on biology. So what they focus is on the penguin. Korean scientists get a focus on penguin to monitor how is the population grows, especially they have an interest in the Adelie penguin colony in Cape Pallet, in the northern part of Cape Pallet, and then also Cape Washington too. Cape Washington is a very big emperor penguin colony. It's close from our base. It's only 30 kilometers away. So it's their plan. They work with the New Zealand scientists. They start from our base. They fly to Cape Pallet to monitor the Adelie penguin colony. And also, they make a small survey the Cape Washington too. I don't know how many of you ever visited Cape Washington or Antarctic penguin colony? You did. Okay, this is Cape Washington. It looks like this. When I flew by helicopter, it said penguin colony is somewhere there, but I don't see any penguins at all. Only a lot of dust in it. It's not actually, it's a whole penguin. See? It's December, early November. This season I visited is early November. That means the chicks are grown up, very close to leave their nest already. So penguin is really an animal have a lot of curiosity. When we flew, they used to come like this. They can crawl, but they don't fly. So what they want is they like to ride on a helicopter to fly. When they come back from the colony, normally penguin like this, they make a very long queue just waiting for the riding helicopter. It's very funny. And what's now our next plan? So by 2014, we set up a station and we initiate very many important science based on from the new Jangbogo station. But that's not the end of our plan. So we are going to have a new plan. There is this, traverse, to get inside, to search for the bigger science. This is our plan. We call it the Korean route plan. We are going to make a new route, get inside of the interior of the continent. We call it a Korean route. So, sorry, it's all Korean, but you can see that. Starting from our station, we find a way to climb up the plateau and getting into the interior place to make a deeper core, ice core. Finally, our final plan is to get a more than 3,000 meter ice core. And that means we need some temporary camp, have to set up temporary camp to support that operation. Okay, this is the plan. So far we did so far. With last year we started our base. We climbed up to the glacier. It's not very good to travel because of a lot of crevasses already, of course. So very careful to move the vehicle. And we surveyed by radar, by helicopter, to see any big crevasses, and then very slowly moving, find the path to get inside. And there is a very thick mountain area, so we have to, not easy to climb up with a heavy cargoes behind. So we are up to this point, and by the end of this season, we probably can go further to go about 360 kilometers from the base. So every year we proceed about few hundred kilometers more and more. So if you get up to the height about 2,000 meters, from 2,000 meters, it's getting flat. It's very flat plateau. So up to that point, you have to be very, very careful. You have to be very, very careful. So this is I told you it's our plan. We're trying to find the Korean route to get into the interior of the continent. The final goal is to get a good place to make a drill, very high, very long core drill. And also in between, see. Yes, our plan is we are going to follow ridges, very high area. We follow the high area to get into the interior of the continent. So we are going to seek for the potential site for drilling camp. And we are going to make a multiple subglacial lake in between. You see all the little dot? This is location of subglacial lake. So huge lakes, many lakes below the thick glacier. So this is a very, very hot, very very big issue in science to get a drill of subglacial lakes. So final goal is to make a deep ice coring up to 3,000 meters. So finally, our presence at the pole is our challenge to our future. Not only Korean, but all humankind in the world. Okay, so I'd like to mention that we are very pleased to set up a science station in the Ross Sea area, the western part of Ross Sea, which is very close to from New Zealand. And naturally, we have a lot of collaboration with New Zealand scientists. So we're quite happy about that. And hopefully, in the future, we can develop more collaboration projects with the New Zealand scientists. Many New Zealand scientists have much longer experience than us in this area, and you had a lot of good science in this area, in this field. So we hope we can make a good and bigger collaboration in the future. From Christchurch or from Littleton, but the starting point of a ship. Thank you very much for your attention.